Okay, welcome back, Uchenna McPhees from North Shell Concepts again. And as you can see, we've completed our wiring, almost completed our wiring. You're seeing uh, a rough construction. This is so that we can test. I want to be able to just see if this works first, and then once that is determined, that our design and our circuit was properly done, then we would go ahead and and have it construct something that is more pleasing to our more aesthetically pleasing. But right now it's dark outside, it's sunset here, so we're gonna test this. If we're gonna do this, we're gonna have to do this using artificial light, and let's just see if it works. Okay, let's try. All right, you see, that even without my batteries being connected, my switch is on and my charge controller is on, right? So basically, I have my panel facing artificial light right now, and definitely it is responding. Don't forget the panel is the current and voltage source, is the power source that we have here. So I gotta, this is not doing anything. If I try to shut this off, it stays on permanent. So I have to look at my wiring. I think, not that I think, I know what's happening. Right now I have a complete circuit with my switch. That means it's taking power from the panel, and there is a return path for it. So it's completing the circuit in and out. There's no shut. There's nothing being shut off by this. All right. It is. Oh, hold on a sec. It kind of is shutting off, but it should be shutting off. My LED is lit up. So when I turn my LED on, my when I turn my switch on, my charge controller goes on. When I turn it off, it goes off. So there is something going on here. Yeah, I think it does complete a circuit. I just don't know why the LED stays on completely on my switch, even though it's doing on and off. I gotta look at that. But I haven't connected the battery yet. And if I don't connect the battery, I can't connect my load, which is the reason we built this in the first place. So let me go get the battery and the load and make this happen. Okay, so I have it all hooked up now, and I have, the load we discussed at the beginning of the project. I even introduced one other load just to see what happens, a fan at 120. Now, when it comes to uh, appliances that have motors and transformers and switches in them, it begins to change the game a little. The load we had prior, they're pretty much DC, they're AC from one point, but they really operate on a DC level. A fan has a motor in it, and once you start dealing with AC, with motors and switches and transformers, or even reactive power, you now start talking about, you know, power factors, and the actual power that you consume is just varies a little bit. But I looked at this fan. It's 120 4.5 amps. Of course, that is not watts, it's volts, amperes. I need to multiply that by the power factor to actually get the wattage that um this appliance consumes. It should be less. I don't anticipate that being a problem. It's a really small motor, and we kind of oversized. So, fingers crossed, it should be able to carry all these appliances at the same time. First of all, it should be able to work, right? So, all hooked up. My switch is still on. My charge controller is beeping. The green beep actually means that it is charging. It has a steady charge to my batteries. So I know that everything is working pretty okay, right? And now the inverter that I got is one that has outlets built in, right? If I got another type, I may have to have, like I had in the design, wire out the lines and have a circuit, have an outlet extending from the inverter. But in this case, it's already built in. We just have to plug in our extension cord and our load, and we don't have to worry about the lines that go out from the inverter. So, which is pretty good. So the moment of truth, I will again, like I said, I'll try to figure out why this switch is constantly on. I probably have something wired or wrong. I'll fix that when I put it all together and more aesthetically, like I said. But for now, let us see if our circuitry actually works. We turn the inverter on. Okay, the inverter is now on. It's showing green, so it is drawing current and power. And I have an extension cord coming out, and I have all that already plugged in. I have our 13 watts lamp. I have our cell phone and our laptop. And if everything goes well, I'll try and see if it will also take the fan. By the way, let me see if it take the fan without any of these guys. First of all, let's see if it will even take the fan at all, even because the fan has a motor in it. Let's see if it take the fan. All right, turn the fan on. Voila, no problem on that side. Okay, good. Now let's turn the fan off. Let's turn now the fan is I checked as a 4.5 watt. By the time you put in power factor and all that, it's probably a 4.2, whatever. Let's turn this guy on. Cell phone on, computer on. How about our 13 watt? And our watt on. All three being powered off. Our battery, no sign. Let's look at our charge controller. Our charge controller is still beeping steady charge. That means it's still comfortable with what the battery is discharging. Otherwise, it would have gone solid green, showing that it needs to recharge the battery faster because I'm consuming too much energy or too much power at the other end. So, okay, so we've answered the big question, which is our circuitry legit? It is. Now, the other question is, how long can I power all this on? Now, our calculation said for 2 hours, I can have all this powered on for one whole day, right? That was undersizing it. I think this guy can actually go on now. As long as we have the battery and as long as we have the solar, right? This will keep going. The 2 hours will only kick in once we lose solar power. Now, understand that I'm using artificial light. So our voltage drain, like we did our test the last time, is in the range of 10 volts, give or take, right? If I were to go outside, I'll be able to draw in like 12 to 18 volts, which means our power would be more, would be more, and it would be more efficient. So everything looks good. We would see what we really need to be worried about, if we need to worry about anything, is how long can all this be powered at the same time. And I have, like I said, I have everything powered except for my fan. If I turn my fan on, let me see what happens if I have my fan also, because, well, I can have my fan on too. And let's look at our charge controller. Still steady. charge controller. Oh wow. Okay, still steady charging, still steady charging of our batteries. So not a lot to be worried about there. All right. Thank you everybody. Once I put all this together and create a more aesthetic uh, uh, design, I will probably introduce it to everybody again. All right. Bye.